Measures of central tendency are descriptive of data collected. Very soon you will be receiving your integrated algebra report card, which will contain a measure of central tendency on your achievement in the course. What is data? Data is information collected for a purpose. Oftentimes, the data collected is numerical. Data must be analyzed to be useful and meaningful. Measures of central tendency are one way to analyze data. Central tendency means in the middle. Mean, median, and mode are measures of central tendency. Mean. It's also known as the average. This is something that students are most familiar with because it is recorded on all report cards. It's found by taking the sum of the data and dividing it by the number of items. For example, if you had scores on a test of 93, 90, 86, 72, and 94, you could find your average by adding all of your test scores together and dividing by how many test scores you have. If you add 93, 90, 87, 72, and 94 and divide by 5 because you have 5 test scores, you will come up with your mean, also denoted as X bar. At the end of the year, students often try to calculate what they need to achieve on the Algebra Regents exam in order to receive a particular grade in the course. For example, if you needed a 75 in the algebra course and you had 4 marking period grades of 83, 77, 65, and 80, and your final exam was counted equivalently to the 4 marking periods, you can calculate what you need to get on that exam in order to achieve this 75 grade. An average is the mean, so you are going to take the sum of all of the marking periods and the final exam and divide by the total number of pieces of data. 4 marking periods and 1 exam is going to be 5 pieces of data. Since we know that we need a 75, we're going to substitute that in for the mean. From here, we're going to solve. You can combine all of your constants, and then we have a proportion. You could easily cross multiply or just multiply both sides by 5 and solve for x. Therefore, we can conclude that we would need to get at least a 70 to achieve a minimum average of 75. Given expressions in terms of x, x plus 5, 3x minus 7, and 5x plus 8, can we calculate the mean of these algebraic expressions? Absolutely. We need to find their sum and divide by the total number of expressions. Here, we have 3 expressions, x plus 5, 3x minus 7, and 5x plus 8. In order to find their sum, we're going to combine like terms. Now we have a rational expression. We may need to do a little bit of factoring in order to simplify the mean. The mean can be distorted by a value that is very different from the rest of the numbers in the list of data. For example, if 4 neighbors have salaries of $50,000, $60,000, $45,000, and $51,000 per year, what would their average salary be? Add them together, divide by how many you have, and the average salary would be $51,750. What happens if a millionaire moves in next door and he makes $1 million per year? we're adding another value. So we would add the $1 million to the 4 values we've already added together, and we would add 1 to our denominator. It looks like everyone is much richer than they are because of that 1 millionaire. Here we have $241,400 as our average or our mean salary. And you can see in this list of data that many people make less than 25% of that value. Median. Median is the middle number when data is in numerical order. The median is a measure of central tendency that can avoid the misleading data of a mean. The median is not affected by abnormally large or small values in a set of data. Here we are given ages, 17, 17, 19, 20, 17, 46, and 18. If we find the mean, our average age is 22, which is 3 to 5 years older than the majority of the workers. Only one person is over 22. All the others are much younger. This is very misleading. You could use the median as your measure of central tendency opposed to your average. You want to put all of your data in numerical order when you're finding the median. And you're going to find the middle number. You should have the same number of values above the median or greater than the median as you do below the median. The median gives a more accurate, normal view of this data. What if there is no middle number? If they hire another employee who is 21, our median will be between the values of 18 and 19. So you're going to find the two numbers in the middle and take their average. The median is now 18.5 years of age. The median can actually be a value that does not exist in the list. It's a value that splits the list into 2 equal parts. Mode is a value that appears most often. As you can see in our data set, we have 3 17s. The mode is 17 because it appears most frequently. There can be more than one mode. For example, in this list down here, we have 2 16s and 2 19s. So the mode is both 16 and 19. There can also be no mode at all. Here, every single value appears once. Therefore, there is no mode because nothing appears more than any other value. Sometimes data is not presented individually, but rather in table format. Here we're asked to find the mean given the data in this table. There are 3 5s, 4 6s, 3 7s, 3 8s, 2 9s, and 1 10. Here we're going to have to find the sum of all of these values. You could write out 5 3s, 4 6s, 3 7s, 3 8s, 2 9s, and a 10, add them all together and divide by how many you have. Or you could use your table to improve your efficiency by multiplying how many, your frequency, times the value. Here we're going to take all of these products and add them together to find the sum of all of this data. The total frequency is 16. We have 16 total values in our table. So we are going to take the sum of all of the values and divide by how many values we have in order to figure out our mean. You can also find the median in this data set. There are 16 numbers, so there are 2 groups of 8. There is no middle number between the 8th and the 9th value. Therefore, we are going to calculate the cumulative frequency from the top, and we can find the interval in which both the 8th and the 9th score lie, which is 7. Therefore, 7. We could also find the mode. The mode is the number that appears most often, so the largest frequency will signify our mode. Here are most. If you are given intervals that are not one value but rather over an interval, you can find the modal interval, or the interval that appears most frequently. Frequency will signify that the largest value we have in our frequency table is 11. So 71 to 80 is going to be our modal interval. Note, the interval, not the frequency, is what you are being asked if you are asked for the modal interval. Again, we have our frequency table. Can you find the interval that contains the median? If you take a look at your total frequency, we would have two groups of 16. Then you're going to count the values and find the interval that contains that value. So we are going to be between the 16th and the 17th value. So we are going to need to count from both the top and the bottom of our table. We're going to calculate the total frequency, or the cumulative frequency, from top to bottom. The first interval contains 6 items. Adding that with our second interval, we will have 14 items, still not the 16th or the 17th item. Moving to 71 to 80, we can find both our 16th and our 17th value, because 14 plus 11 is 25. So between 14 and 25, we will find both the 16th and the 17th value. Counting from the bottom, we're going to find the 16th and the 17th value in the same interval. The median is in the 71 to 80 interval.